Hello, today I will be talking about how to solve problem 4 from midterm 1. The problem 4 says that you have to consider a rock climber of mass 60 kilograms who is ascending a vertical wall and stops for rest by leaning back on her rope as seen in the diagram. The rope has some unknown tension and makes an angle of 31 degrees with the vertical. As the climber rests, the wall exerts a force F of unknown magnitude. This force F points at an angle of 15 degrees above the horizontal, as shown in the figure. First of all, we need to do a free body diagram to understand what's happening in this picture. As you can see, we have all of the components, and on the left, we know what F wall is, which is the force exerted by the wall, F wall X, which is the X component of F wall, F wall Y, which is the Y component, and we have Ft, which is tension force, Ft right here, then Ftx, the X component, and Fty, the Y component. Also, we have Fg, which is the force exerted by the Earth. We also know that F wall X, which is the X component, is equal to cosine of 15 times F wall, because we use trigonometric functions to solve this. Also with F wall Y, which is sine of 15 times F wall, then Ftx, which is sine of 31 times Ft, and Fty, which is cosine of 31 times Ft. We also know that Fg equals mass times gravity. Question A says that we need to determine the magnitude of the tension in the rope required for the mountain climber to remain stationary. And we need to start from a fundamental principle. So we don't know what Ft is. We start by a fundamental principle and saying that dp dt equals 0 because there is no movement. Then by Newton's second law, we know that F net equals 0. We also know that F net equals F wall plus Ft plus Fg. Therefore, all of those combined and summed up are equal to 0. In the x direction, we have F wall x and Ftx in the x components. And these two have to equal to 0 because of what we explained before by Newton's second law principle. So by plugging in the values we had in the previous slide, we know that F wall x equals cosine of 15 times F wall, right here, and Ftx equals sine of 31 times Ft. And this all has to equal to 0. So because we need to calculate Ft in this problem, we're putting F wall in terms of Ft, and it will equal F wall equals Ft times sine of 31 over cosine of 50. We also know that in the y direction, Fty equals plus Foy minus Fg equals 0. So we plug in the values from the previous slide and we obtain that cosine of 31 times Ft plus sine of 15 times F wall minus mass times gravity needs to equal 0. And then by plugging in the value of F wall, by plugging in the value of F wall, we obtain that the final value of Ft equals mass times gravity over cosine of 31 plus sine of 31 times tangent 15, which is equal to 591 newtons. Then, for question B, we need to determine the magnitude of the wall force F wall required for the mountain climber to remain stationary, and start from a fundamental principle. So, from A, we know that F net in x components need to equal 0, and from the last equation we used before, cosine of 15 times F wall minus sine of 31 times Ft need to equal 0. Then we clear F wall from this equation, and we obtain that F wall equals Ft times sine of 31 over cosine 50, which is equal to 591 newtons times 0.533. And we obtain that the value of F wall in order for the mountain climber to remain stationary is equal to 350 newtons. For the last question, we have to calculate the minimum static coefficient of friction between the climber's shoes and the cliff, required to remain motionless in the position shown. As you can see in the diagram on the right, the F wall is the force exerted that was shown in the first diagram. This is 15 degrees, and then Fn, which is the normal force, is pointing in the x component of F wall because it is always perpendicular to the surface, and F friction is pointing upwards in this case. We know that F friction equals coefficient of static friction times F normal force. We also know that the normal force, which is the x component of F wall that we calculated before, is cosine of 15 times F wall, and that the force of friction equals, by using trigonometric equations right here from the diagram, is sine of 15 times F wall. Then, by just plugging in values, we obtain that the coefficient of static friction equals to F friction over F normal, and then sine of 15 times F wall over cosine of 15 times F wall equals to tangent of 15. So the coefficient of static friction will be equal to 0.268. Thank you for watching.